All right, gang, we are wrapping up chapter 10. Probably the hardest chapter we've done. We're in 10.7. Let's warm up. Please pay attention to warm up. Things like number 2 are going to be very important for you to remember how to do. All right, so to simplify number 1, I can take the radical of the top and the bottom, and that gives me negative, radical 3 over 2. Okay, on the number 2 though, it's a little bit more difficult. I'm going to change that number 1, I'm going to change the number 1 into 25 over 25 plus 7 over 25 all over 2. I know that 2 is always over a 1. So that numerator turns into a 32 over 25. But this denominator, I'm going to go ahead and change the division problem into a multiplication problem. Cool. Now the 2 can turn that into a 16. That means I have the square root of 16 over 25, which actually I can take the square root of 16 over 25 and get 4/5. Okay, I do this a lot in our homework during this section, okay? You're designing a logo on a coordinate plane. The tangent of an angle in the logo is positive. Which quadrants can the angle lie? Well, I know that tangent is y over x. So if I look at the coordinate plane, y and x are both positive here. That means I'm going to have positive over positive, but they're both negative here. Negative over negative, which is positive. So both in quadrant 1 and 3, I have positive tangents. All right, these need to be written down so you can access them easily. Okay, double angle formulas and half angle formulas. Notice that the signs here and here depend on which quadrant A over 2 lies. Okay, which quadrant A over 2 lies, not A over 2. Okay, so go ahead and write those down or highlight them in your notes. All right, let's go ahead and try one. Okay, don't get frustrated. You have to stick with me. This stuff isn't easy. Find the exact value of the cosine of 165. Well, the cosine of 165 isn't helping me any. So let's go ahead and double it and see what happens. Okay, 165 times 2 is 330. Well, I know if I'm in a coordinate plane and I go 330, I have 30 degrees left. My reference angle is 30 degrees. Right? So 330 is something I can use. So let's go ahead and change this into something with 330. So I can take the cosine of 1/2 330. Those are equivalent. 1/2 330 and 165 are equal. So I'm actually taking the cosine of 330 over 2. So I'm going to go back and use that half angle formula, which gives me, let's see, first I do need to figure out what quadrant I'm in. If you remember from the page that had the equations on it, we'd figure out the quadrant by looking at A over 2, which in our case is 165. This is just picking our sine. 165 degrees is over here, and in quadrant 2, cosine is negative. Okay, it's something that we know, we have figured out, we talk about a lot. So I'm going to go ahead and use the negative square root 1 plus cosine A over 2, where we know that A is 330 degrees. So let me rewrite my triangle, because I can't really see it. This is 30 degrees. Across from the 30 degree is 1. Across from the 90 is 2. And across from the 60 is square root 3. So if I go ahead and use that in this equation, I have 1 plus cosine A is adjacent over hypotenuse, so square root 3 over 2 all over 2. And this actually should go down just a little bit. Okay, this is what we did in our warm-up, so now we need to fix this equation a little bit. So negative, I'm going to turn that 1 into a 2 over 2. Square root 3, that's a 3. All over 2. And again, I need this to get a little bit longer. So I'm going to come up here. That gives me 2 plus root 3 over 2, all over 2 over 1. Remember the warm-up, I did the same thing. I'm going to change that division problem into a multiplication problem. 2 plus root 3 over 2 times 1 over 2. That gives me 2 plus root 3 over 4, which I can take the square root of 4, just like in the warm-up. My numerator stays to 2 plus root 3 all over 2. And that right there is my answer. I know that seemed like a lot, but trust me, the more you do, the easier it's going to get. Okay? Let's try the next one. Find the exact value of tan pi over 12. What is pi over 12? Okay, we don't have any special triangles that relate to pi over 12, but I can change this into tan 1/2 times pi over 6. And pi over 6, I know, pi over 6 is 30 degrees. Yep, 30 degrees, okay? So to make it look right, I'm going to say pi over 6 over 2. That means A is pi over 6. Now, remember we were supposed to look at A over 2 is where we try to figure out our correct sine. So this is what I look at for our right sine. Pi over 6 over 2 is actually 15 degrees, so I'm in quadrant 1. And I know tangent is positive in quadrant 1, so I'm good. All right, so let's go ahead and grab our half angle equation. So I have tan of pi over 6 over 2 is equal to 1 minus cosine of pi over 6 over sine of pi over 6. Now we just said pi over 6 is 30. I'm in quadrant 1. So across from 30 is 1, across from the 90 is 2, and square root 3. So this gives me 1 minus cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. So I'm going to change this into 2 over 2 minus square root 3 over 2 over 1/2. which gives me 2 minus root 3 over 2. I'm going to change that denominator into a multiplication problem. So 2 minus root 3 over 2 times 2 over 1. Those cancel, and I'm left with 2 minus root 3 as my answer. Okay, let's try our second example for what we're doing here. So given cosine A equals 5/13, and our A is between 3 pi over 2 and 2 pi, find two different things. We're going to do one at a time. First, we're going to find the double angle, sine 2A, and then we're going to find the half angle, sine A over 2. So I know that I'm currently I'm in quadrant 4, and I know cosine A is 5/13. So I can use my Pythagorean identity, or I can use the Pythagorean theorem. So I know I'm right here. Cosine is adjacent over hypotenuse. So I can do 5 squared plus b squared equals c squared, 13 squared. Calculator, 13 squared minus 25. Take the square root of that, and I believe it's 12. Yes. So I just calculated that's 12. So I know that I have cosine A. I know I have sine A is negative 12/13. I forgot that. That is definitely a negative. I'm just writing it a little bit better. I'm sorry. Cool. Also, just so you know, a reminder, I know tangent A is equal to sine A over cosine A. It's another thing that we've learned in the past. I just remembered to tell you. So, we got the Pythagorean identity. What we're going to do first is sine of 2A. And the equation that we already went over, we just haven't used it yet, is sine 2A is equal to 2 sine A cosine A. Well, we found sine A, negative 12/13, and we found cosine A. Or no, we were given cosine A, 5/13. Well, I'm just going to multiply now. This is exciting. 2 times 12 times 5, because it's a fraction, so I multiply across the top. I get negative 120. And 13 squared, I think I know that one. Yep, 169. And that's actually my answer. Okay, let's go to the next slide and try this one. Sine A over 2. All right, so A over 2 is in quadrant 2. Sorry, I know that my quadrants I'm given are 3 pi over 2, A, and 2 pi. I'm doing A over 2, so if I divide this one by 2, and this one by 2, I actually get 3 pi over 4 and pi. So if I look at my coordinate plane, 3 pi over 4 is 135 and pi is 180. So I'm in quadrant 2. And I know sine in quadrant 2 is positive. So let's go ahead and do the half angle equation. Sine A over 2 is equal to 1 minus cosine A, which we were given, over 2. 1 minus 5/13, all over 2. I'm actually going to try this with my calculator. 1 minus 5/13 divide by 2. Change that back to a fraction. Yeah! And I get the square root of 4/13. Well, I know I don't like that, so I need to rationalize it. The numerator simplifies to 2. Denominator is square root 13. So I multiply that by the top and the bottom. So I get 2 square root 13 over 13 as my answer. Cool. All right, we have 5 more examples before I push pause on this video. Okay, so you can't quit on me yet. Find the exact value of the expression. I don't know anything about pi over 8, so I need to change this into 1/2 times pi over 4, because pi over 4 is 45 degrees. So my a over 2 is going to be pi over 4 over 2. Pi over 8 is 22.5, so that's in quadrant 1, which is positive. It doesn't matter with tangent, I know. I just get in the habit of doing that. So I keep wanting to do it. So let's go ahead and use our tangent half angle formula. Sorry, I had to look it up. I'm going to use 1 minus cosine A over sine A. So for 45 degrees, and I'm in quadrant 1, I get 1, 1, and square root 2. So 1 minus cosine A is adjacent over hypotenuse, and sine A is opposite over hypotenuse. Let me straighten that out. Okay, I'm going to change that into square root of 2 over square root of 2. Move this. So I get square root 2 minus 1 over square root 2 times 1 over. I'm going to take that denominator and change it from a division problem into a multiplication problem. So square root 2 minus 1 over square root 2, reciprocal, cancels out, and my answer is square root 2 minus 1. I like the tangent ones. They seem a bit more simple than these. I left the answer on here on accident, but we're going to go ahead and work it out anyway. 5 pi over 8. I don't know. So I'm going to change that into degrees. That's 112.5. If I multiply that by 2, I get 225 degrees. Now I want to see what quadrant that is in. So I subtract it by 180 and I get 45 degrees. So I am down here. But remember, we have to look at this angle. This is in quadrant 2, and in quadrant 2 my sine is positive. So we're good there. Let's go ahead and use our formula, which I have to look up again. Sine A over 2 is, we're doing positive, 1 minus cosine A over 2. So 1, 1, negative 1, square root 2. 1 minus adjacent over hypotenuse, all over 2. Square root 2 minus 1 over square root 2, all over 2. Remember, I'm going to change that into a multiplication problem, not a division problem. I get square root 2 minus 1 over square root 2 times, this would be over 1, 1/2. Square root 2 minus 1 over 2 root 2. Messy, I know. I have to rationalize that, so I'm multiplying it by root 2 over root 2. And the numerator, that gives me, I just distribute there and there. So I get root 4 minus root 2 all over 2 root 4, which means this needs to be a little longer again. Right. The numerator changes into 2 minus root 2, and the denominator, this becomes a 2 times this 2 is a 4, takes the square root of it, I get a 2 again. And we have the right answer. Lots of magic going on with those 2's. Okay, like I said, we have 5 problems to do. Here is the third, and I left the answer on again. Cosine 15 doesn't help me much, but I do know that I can make it cosine 1/2 times 30, and then I have a special triangle. So cosine 30 over 2. This right here is quadrant 1, which cosine is positive, which is nice. So I'm going to do cosine A over 2 square root 1 plus cosine A over 2. So if I look at my special triangle, I'm over here. It looks like a 45-45, sorry. Yeah. I shouldn't care, but I know it confuses some of you. So 30. 2 root 3. So I have cosine A, adjacent over hypotenuse, all over 2. I change that 1 into a 2 over 2, so I get 2 plus root 3 over 2, all over 2. I'm going to change that into a multiplication problem. 2 plus root 3 over 2. 2 plus root 3 over 4. 2 plus root 3 over 2. There she goes. I hope it's getting a little bit easier for you to watch. Alright, given sine A is square root 2 over 2, and we're in quadrant 1, find cosine 2A and tan A over 2. So I can use a Pythagorean identity, which is sine squared A plus, this is different than I did before, cosine squared A equals 1. Ah. So if I square that, I get 2 over 4. Subtract 1/2 from both sides. So minus 1/2 minus 1/2. Square to both sides. A equals 1 over the square root of 2, which is square root 2 over 2. And I'm in quadrant 1, so it's positive. So I know that, cosine A equals that. So sine A equals square root of 2 over 2. Cosine A also equals the square root of 2 over 2. And remember, tan A is sine A over cosine A. Just giving you some general knowledge. All right, so let's find cosine 2A. I need to go back to my list of formulas. Cosine 2A is, you can use lots of different ones. Let's use 1 minus 2 sine squared A. 2 times square root 2 over 2 squared. 1 minus 2, if I square that, I get 2 over 4. 2 times is 1, which equals 0. I have to check. Yep, 0. Awesome, so that's cosine 2A. I need another page to do tan A over 2. So the formula is 1 minus cosine A over sine A. So we found them. So square root 2 over 2 over square root 2 over 2. All right, let's simplify. I'm going to change that 1 into a 2 over 2, just like we've been doing. Okay, the numerator becomes 2 minus root 2 over 2, and I'm going to go ahead and multiply the reciprocal now. 2 over root 2. All right, if I multiply across the top and the bottom, those cancel out. In the numerator I have 2 minus the square root of 2, and the denominator I have the square root of 2. Okay, go ahead and rationalize. This is where you all roll your eyes. Okay, multiply across the top and bottom. I get 2 square root of 2 minus the square root of 4 over the square root of 4. And unfortunately, I can simplify again by splitting that up. Square root of 2 minus 1. Final answer. Whew, one more. Okay, last problem. All right. So given cosine A is there, and I'm in the third quadrant, this right here is over here. Find sine 2A and sine A over 2. Okay, you can use Pythagorean Identity, which we did in the last problem, or you can just remember that it's a 3, 4, 5 triangle. So here's A. Cosine is adjacent over hypotenuse. And if you use Pythagorean theorem, that's going to be a negative 4. So that means that sine of A is negative 4/5. So my sine double angle formula is 2 times sine A cosine A. So 2 times negative 4/5 and negative 3/5. Multiply across the top. 2 times 4 is 8 times 3 is 24 over 25. Oops. I believe that is my answer. Yay! Let's do sine A over 2. Okay, this problem wants us to find sine A over 2. My formula is, there we are. 1 minus cosine A over 2. And I'm in quadrant 1, correct? Find the problem again. Between pi, it looks like I'm here. I forgot already. I'm over here. And there my sine is negative. Oh, but I'm sorry, we're doing a over 2. So pi, this is where we started. So remember, we need to figure out. So we're now between pi over 2 and 3 pi over 4. So that is going to be up here, where sine is positive. Okay, so let's go ahead. I'm going to do 1 minus cosine A all over 2. 1 plus 3/5 over 2. Hold on, please. 1 plus 3/5 divide by 2. Change it into a fraction. 4/5. Square root of 4/5 is 2 root 5. Rationalize it. 2 root 5 over 5. Woo woo. Well done. Nice work.